Welcome to our deep dive into the world of bushings, those small but mighty components that play a huge role in countless machines and devices around us. From absorbing shock and reducing friction to supporting rotational and sliding movements, bushings are essential to keeping everything running smoothly. In this video, we'll explore the various types of bushings, including plain bushings, cylindrical-shaped bushings with a simple design; flange bushings, cylindrical-shaped bushings with a lip called a flange at one end; thrust bushings, cylindrical-shaped bushings designed to handle axial thrust loads; tapered bushings, cylindrical-shaped bushings with a tapered inner bore that matches the taper of the shaft, and more. What's so exciting about them? Well, get ready to have your mind blown because bushings are the unsung heroes of countless mechanical systems. Today we're going to unravel the mysteries of these often overlooked components, exploring the different types, their unique characteristics, and why they're crucial for keeping things running smoothly. We'll cover everything from their applications in heavy machinery to their role in everyday household items. So, whether you're a seasoned engineer, a DIY enthusiast, or just curious about how things work, stick around. You're about to become a bushing expert. In the simplest terms, a bushing is a type of bearing, a mechanical element that reduces friction between moving parts. Imagine two metal surfaces rubbing against each other. Not ideal, right? That's where bushings come in. They act as a protective barrier, reducing wear and tear, and ensuring things move smoothly and efficiently. Think of it like this. You wouldn't want your car's suspension to grind against the frame every time you hit a bump, would you? Bushings provide that crucial cushioning and support. They're found in all sorts of everyday objects, from power tools and appliances to bicycles and even furniture. Anywhere you have moving parts that need to work together smoothly and quietly, you'll likely find a bushing doing its job. Take a look around you. Chances are there are bushings working silently behind the scenes, ensuring things function as they should. Your washing machine uses them to reduce vibration and noise during spin cycles. Your drill relies on them for smooth operation and extended tool life. Even your office chair uses bushings to allow for effortless swiveling and height adjustment. Despite their simple appearance, bushings play a vital role in our mechanical world, making our lives easier, more efficient, and a whole lot smoother. Let's kick things off with the most common type of bushing, the sleeve bushing. These are your basic cylindrical bushings designed to reduce friction between a shaft and a housing. Picture a simple metal tube. That's your sleeve bushing in its most basic form. Sleeve bushings are incredibly versatile and find their way into a wide range of applications. They're commonly used in automotive suspensions, power tools, and industrial machinery. One of the great things about sleeve bushings is their simplicity. They're easy to manufacture, install, and replace, making them a cost-effective solution for many applications. Plus, they come in a variety of materials, from bronze and brass to nylon and PTFE, Teflon, allowing you to choose the best option for your specific needs. Whether you need high load capacity, corrosion resistance, or self-lubricating properties, there's a sleeve bushing out there for you. Now, let's talk about flanged bushings. These are essentially sleeve bushings with an added feature, a flange or a flat circular extension on one end. This flange acts as a washer, providing a larger surface area for mounting and preventing the bushing from moving axially within the housing. This added stability makes flanged bushings ideal for applications where secure mounting is crucial. They're also commonly used in gearboxes, pumps, and other machinery where precise alignment and secure mounting are essential for optimal performance and longevity. So, if you need a bushing that can handle a bit more than just rotational or linear motion, a flanged bushing might be just what the doctor ordered. While sleeve and flange bushings excel at handling radial loads, forces perpendicular to the shaft, thrust bushings are the go-to solution for axial loads or forces acting along the shaft's axis. Think of it this way: if you're pushing down on a shaft, you need a thrust bushing to handle that compressive force. Thrust bushings typically feature a flat or slightly curved bearing surface designed to distribute axial loads over a wider area, reducing wear and preventing damage to the shaft and housing. They're often used in applications like gearboxes, hydraulic cylinders, and rotating machinery where axial forces are present. One common example is in a car's clutch system. This bushing allows for smooth engagement and disengagement of the clutch, ensuring smooth gear changes and preventing premature wear on the clutch components. Last but not least, let's explore pivot bushings, the specialists of the bushing world. These unique bushings are designed specifically for applications involving oscillating motion, where a shaft or lever pivots back and forth through a limited arc. Pivot bushings often feature a spherical or hemispherical bearing surface that allows for smooth, low-friction movement even under high loads and misalignment. They're commonly used in linkages, suspension systems, and other applications where smooth, controlled pivoting motion is essential. Think about the swing arm on a motorcycle. As the motorcycle leans into turns, the swing arm pivots, allowing the rear wheel to maintain contact with the road. This pivoting motion is often facilitated by a pivot bushing, which ensures smooth movement and absorbs shocks and vibrations. Let's start with something we're all familiar with: cars. Bushings are essential components in various automotive systems, ensuring a smooth, comfortable, and safe ride. Think about your car's suspension, those struts, shocks, and control arms that keep your tires glued to the road. Bushings are there, absorbing shocks and vibrations, allowing for controlled movement, and preventing metal-on-metal contact that would lead to a bumpy, noisy, and ultimately dangerous ride. But it doesn't stop there. Bushings are also hard at work in your car's engine, transmission, steering system, and even your door hinges. Next time you're cruising down the highway, take a moment to appreciate the humble bushings working tirelessly behind the scenes to keep you moving. Now let's shift gears and head into the world of industrial machinery, where bushings play a critical role in keeping factories humming and production lines rolling. From heavy-duty equipment like excavators and bulldozers to precision machines used in manufacturing, bushings are everywhere, ensuring smooth operation, reducing downtime, and extending the life of expensive components. Imagine a giant mining truck hauling tons of ore. The suspension system alone relies on countless bushings to handle the immense weight and rugged terrain. In these demanding environments, bushings are the unsung heroes, working tirelessly to keep industries running smoothly. When it comes to pushing the boundaries of engineering and innovation, few industries can match the demands of aerospace. In this realm of extreme temperatures, intense vibrations, and zero tolerance for failure, bushings play a critical, albeit often overlooked, role. From the landing gear of a jumbo jet to the robotic arm of a Mars rover, bushings are there, ensuring smooth operation, reliability, and safety in some of the most challenging environments imaginable. Think about the forces acting on an aircraft during takeoff and landing. The weight of the plane, the speed, the impact bushings in the landing gear absorb these shocks, allowing for a controlled and safe touchdown. In the world of aerospace, even the smallest component can have a huge impact, and bushings are no exception. Bushings in everyday life, the unseen helpers. We've covered some pretty heavy-duty applications, but let's bring it back down to earth for a moment. Bushings might seem like components relegated to the world of heavy machinery and industrial equipment, but the truth is they're all around us, silently working their magic in countless everyday objects. Remember that smooth sliding drawer in your kitchen? Bushings. That quiet closing door hinge? Bushings. The effortless swivel of your office chair? You guessed it. Bushings. From the appliances that make our lives easier to the tools that help us build and create, bushings are everywhere, reducing friction, preventing wear, and ensuring things move smoothly and quietly. They might be small, but their impact on our daily lives is undeniable. Material matters, choosing the right stuff. All right, bushing enthusiasts, let's dive into the nitty-gritty of what makes these little components tick. Their characteristics. First up, we have materials. Bushings come in a surprising variety of materials, each with its own strengths and weaknesses. Choosing the right material is crucial for ensuring optimal performance and longevity. For applications demanding high load capacity and wear resistance, metals like bronze, brass, and steel are top contenders. On the other hand, if you need a bushing that can handle high temperatures or harsh chemicals, you might opt for engineered plastics like nylon or PTFE, also known as Teflon. Load capacity. How much weight can a bushing handle? Next up, let's talk load capacity. This refers to the amount of weight or force a bushing can withstand before it starts to deform or fail. It's a critical factor to consider when selecting a bushing, as using one with insufficient load capacity can lead to premature wear, excessive vibration, and even catastrophic failure. Load capacity is influenced by several factors, including the bushing's material, size, wall thickness, and the type of load being applied, whether it's radial, axial, or a combination of both. Always consult these ratings and choose a bushing that exceeds the expected loads in your application, providing a safety margin for unexpected stresses or impacts. Durability and wear resistance, built to last. Nobody wants to be constantly replacing worn-out bushings, so durability is a key consideration. The ideal bushing material should resist wear and tear, maintaining its shape and performance over extended periods of use. Factors like material hardness, surface finish, and operating environment all play a role in determining a bushing's lifespan. For applications involving high loads, abrasive materials, or extreme temperatures, choosing a bushing with exceptional wear resistance is crucial. In contrast, self-lubricating materials like bronze and PTFE offer excellent wear resistance in lower load applications, especially in environments where lubrication is difficult or impractical. Friction and lubrication, keeping things moving smoothly. Last but not least, let's talk about friction and lubrication. Two critical factors that directly impact a bushing's performance and longevity. The primary function of a bushing is to reduce friction between moving parts, allowing for smoother, more efficient operation. However, even the smoothest surfaces generate some friction, and over time, this can lead to wear, heat generation, and reduced efficiency. That's where lubrication comes in. Lubricants, like grease or oil, create a thin film between the bushing and the mating surface, reducing direct contact and minimizing friction. Some bushing materials, like bronze and PTFE, possess inherent self-lubricating properties, meaning they release microscopic particles that act as a dry lubricant. The importance of precision. Why bushing measurements matter. Alright, bushing aficionados, let's talk measurements. You might be thinking, measurements? Can't I just eyeball it? Well, in the world of bushings, precision is paramount. Using the wrong size bushing can lead to a whole host of problems, from excessive vibration and noise to premature wear and even catastrophic failure. Imagine a bushing that's too loose in its housing. It'll rattle around, creating excessive noise and vibration and potentially damaging the surrounding components. On the other hand, a bushing that's too tight will create excessive friction, leading to premature wear, heat generation, and reduced efficiency. Key bushing dimensions: ID, OD, and length. The Holy Trinity. 3 key dimensions: inside diameter, outside diameter, and length. The Holy Trinity of bushing sizing. Get these right for a smooth-running, long-lasting installation. Inside diameter, or ID, the hole where the shaft or pin goes. Outside diameter, or OD, the outer surface fitting inside the housing. Length, the distance between the bushing's ends. Measuring up tools and techniques for accurate bushing measurement. Now that we've covered the key dimensions, let's talk about how to measure them accurately. Fortunately, you don't need a fancy laboratory to get the job done. A few simple tools and a bit of know-how are all it takes. For measuring the ID and OD, a set of calipers is your best friend. These handy tools come in various types, but vernier calipers or digital calipers are ideal for bushing measurements. To measure the ID, simply slide the jaws of the calipers inside the bushing and adjust them until they lightly touch the inner surface. Don't forget the tolerances. While getting the basic ID, OD, and length measurements right is crucial, it's equally important to understand the concept of tolerances. Tolerances refer to the allowable variation in a dimension. In other words, they define how much larger or smaller a dimension can be while still being considered acceptable. For example, a bushing might have an ID of 1 inch with a tolerance of plus or minus 0.005 of an inch. This means the actual ID can be anywhere between 0.995 inches and 1.005 inches, and still be considered within spec. Tolerances are crucial for ensuring proper fit and function. A bushing with an ID that's too far outside the tolerance range might be too loose or too tight, leading to the problems we discussed earlier. Selecting the right bushings. Let's dive into the advantages and disadvantages of each bushing type. Understanding these will help you make informed decisions. There's no one-size-fits-all solution. Each type has its own strengths and weaknesses. Do you need a bushing that can handle high loads? Is corrosion resistance a major concern? How about temperature extremes or lubrication requirements? Let's start with the workhorse of the bushing world, the sleeve bushing. Sleeve bushings are simple, cylindrical components designed to reduce friction. Their simplicity is both their strength and limitation. Easy to manufacture, install, and replace, they are cost-effective. Made from metals like bronze and brass to plastics like nylon and PTFE, ideal for limited space applications. Offer minimal axial stability, moving back and forth unless constrained. Can wear out quickly in rotating housings. Now, let's move on to the flanged bushing, which is essentially a sleeve bushing with an added flange on one end. This flange provides several advantages but also introduces a few challenges. The flange acts as a washer, providing a larger surface area for mounting and preventing axial movement. Installing a flanged bushing can be more challenging than a sleeve bushing. Proper alignment and correct torque are crucial for a secure fit. Moving on to the specialists, thrust bushings are the go-to solution for handling axial loads, the forces acting along the shaft's axis. They excel in applications where other bushing types would struggle. Thrust bushings are specifically designed to handle axial loads, making them ideal for applications like gearboxes, hydraulic cylinders, and rotating machinery where these forces are prevalent. Their flat, or slightly curved bearing surfaces distribute axial loads over a wider area, reducing wear and preventing damage to the shaft and housing. However, thrust bushings are not designed for continuous rotational motion. While they can handle some incidental rotation, using them in high-speed or continuous rotation applications will lead to rapid wear and premature failure. Compared to sleeve or flange bushings, thrust bushings typically have lower radial load capacities. They're best suited for applications where axial loads are the primary concern. Choosing the right bushing, a guide for the discerning maker. Alright, bushing buffs, let's distill that knowledge into practical advice for choosing the right bushing. Balance performance, longevity, and budget. Start with the load. The first factor is the weight or force your bushing needs to handle. Consider both radial and axial loads. Factor in the speed. High-speed applications need self-lubricating materials. Mind the environment. Choose materials that withstand the elements. Don't forget the fit ID, OD, and length are crucial. Installation and maintenance, keeping your bushings happy. Congratulations, you've chosen the perfect bushing for your project. Ensure proper alignment, use the correct tools, and never force a bushing into place. Regular lubrication reduces friction and extends bushing life. Keep it clean. Dirt and debris are the enemies of smooth operation. Listen for warning signs. Early detection prevents significant damage. Bushings are the silent workhorses of countless mechanical systems. The power of tiny titans, recap and final thoughts. Well, there you have it, bushing aficionados. We've journeyed deep into the fascinating world of these often overlooked mechanical marvels. From the humble sleeve bushing to the specialized thrust bushing, we've explored their diverse types, unique characteristics, and critical roles in keeping our world moving smoothly. Remember those bumpy car rides and squeaky door hinges? Those are distant memories thanks to the silent, tireless work of bushings. They might be small, but their impact is undeniable. Whether you're a seasoned engineer, a DIY enthusiast, or simply someone who appreciates a well-functioning machine, I hope this deep dive has given you a newfound appreciation for the power of these tiny titans. Go forth and bushing-ize. Now that you're armed with bushing knowledge, it's time to put it into practice. Next time you're tackling a project, whether it's rebuilding a classic car, fine-tuning a piece of machinery, or simply trying to silence that annoying squeaky drawer, remember the lessons we've learned. Choose your bushings wisely, considering the load, speed, and environment they'll be subjected to. Install them with care, ensuring proper alignment and lubrication. And don't forget to show them some love with regular maintenance. Trust me, your bushings will thank you for it with years of reliable service. So go forth and bushing-ize. Embrace the power of these small but mighty components, and let's keep the world running smoothly, one bushing at a time. Thank you for joining us. If you like this video, please join us on our next exploration. Don't forget to like, share, and subscribe. Until next time.